Welcome to Z-Tech Advisor and to CASP Plus for Security Architecture course, Wireless and Mesh. In this lesson, we delve into the infrastructure supporting one of the most rapidly expanding components of our networks, the wireless domain. The prevalence of wireless connections in modern network architectures is on the rise. When deploying numerous access points across our enterprise to ensure full coverage for our wireless users, having a wireless controller becomes indispensable. These controllers provide a centralized platform to monitor, manage, and control access points, offering additional security features beyond those of standard wireless access points. Utilizing a wireless controller enables an enterprise-wide approach to wireless coverage, allowing for dynamic adjustments to optimize performance. For instance, we can fine-tune channel assignments and adjust radio frequency transmission power in real time to mitigate interference with other wireless signals. Furthermore, wireless controllers facilitate load balancing, enabling users to seamlessly connect to different access points to enhance their data transmission rates or achieve better coverage. These devices can also detect coverage gaps and increase the transmission power of an access point to fill in an uncovered area of your building. Authentication over wireless networks is another important feature to consider. By implementing these controllers, authentication schemes like 802.1x, Protected Extensible Authentication Protocol or PP, Lightweight Extensible Authentication Protocol, or LEAP, the Extensible Authentication Protocol Transport Layer Security Protocol, EAPTLS, Wi-Fi Protected Access, and 802.11i and Layer 2 Tunneling Protocol, L2TP, can all be used to secure your wireless domain. Even though using wireless controllers does add some cost and complexity to your network, it does have a lot of benefits that easily outweigh the distractions for large-scale enterprises. Finally, before we end this discussion of wireless infrastructure, we need to touch on the concept of mesh networks because they're continuing to grow in popularity. Now, mesh networks are a form of networks topology in which each node cooperates to relay data in an effort to ensure that all nodes maintain connectivity to one another. Traditional mesh networks were made up of wire connections that created an exceptional level of redundancy for any single connection inside the network. As wireless networks have increased in popularity, mesh networks began to change. In modern mesh networks, we find a myriad of different networking devices, all cooperating together to form a redundant and highly available network. These include wired connections, such as Ethernet and fiber connections, as well as wireless networking technologies like Wi-Fi, cellular, microwave, and satellite connectivity options. These networks ensure that availability is continuously maintained by utilizing a self-healing algorithm to route traffic around broken or block communication paths. Wireless mesh networks have numerous uses, but one of the best use cases is in places where traditional networks become unavailable. For example, after a hurricane or a typhoon, disaster relief personnel are able to bring in networking equipment such as satellite connectivity, mobile cellular towers, and other means to help restore some level of connectivity during the recovery efforts by using mesh technologies. Mesh networks use 3 different types of protocols to accomplish their self-healing and rerouting functions, including ADHOC Configuration Protocol, AHCP, Proactive Auto Configuration, PA, and Dynamic WMN Configuration Protocol, or DWCP. That is it for now. If you found this video enjoyable or informative, please consider giving it a thumbs up. Your feedback helps us understand what content resonates with our audience and encourages us to create more content that you'll love. Thank you for your support.